In the lecture of today, we are going to discuss about the law of flotation. At the end of this lecture, you should be able to define the law of flotation. You should also be able to represent it mathematically. And finally, you should be able to know the interrelationship between the law of flotation and the Archimedes principle. But before then, let us remind ourselves a few things that we learned in the previous lecture. In the previous lecture, we talked about two major forces that act on an object immersed in any fluid. One of the forces was the upthrust that acts upwards, and the second force was weight that acts downwards. Now, we said the interaction between these two forces is very important in that if the weight is stronger than the upthrust, then definitely that object will sink. And when the upthrust is greater than the weight, then definitely that particular object will rise up the air. And finally, we talked about if this weight is equal to upthrust, then this particular object will rest on the surface of that liquid. So that we'll be talking about that object floating. And now, this third option will now form the basis of our discussion today. Let us now go ahead to define the law of flotation. The law of flotation states that a floating object displaces its own weight of the fluid it floats. Let us remind ourselves of the Archimedes principle. Now, in the Archimedes principle, we said that any object that is immersed in a fluid will always experience an upthrust which is equal to the weight of the fluid that is displaced. Now, from here, there is no doubt that any object that is immersed in a fluid must at least displace a fluid, and this weight of the fluid that is displaced is always equal to upthrust. Now, for such object that is immersed in a fluid, for it to float, then this particular displaced fluid, its weight must be equal to the weight of that object, so that we will be saying that that object floats on that. So at this particular point, we need to understand that the law of flotation here, the weight of the object that floats must be equal to the weight of the fluid that is displaced. Now, to reiterate, we should not forget that from Archimedes' principle, that particular object that is immersed in a fluid, it will always experience an upthrust that is equal to the weight of the fluid that is displaced. So at least we know that this upthrust is equal to the weight of the fluid that is displaced. But now in the law of flotation, for that particular object to float, then this same upthrust should be equal to the weight of that individual object that floats in that particular fluid. In a nutshell, the weight of the fluid that is displaced should be equivalent to the weight of the object that floats on that particular fluid, and this should also be the same as the upthrust. But we must know that this particular relationship only works for an object that floats on that particular fluid, and that is the reason why we are talking about the floating object. So in simple terms, the moment you know the weight of that particular object, already you should be knowing the upthrust. Why? Because the upthrust is equal to the weight of that particular object. This only happens if that particular object floats on that particular fluid. Now, how is Archimedes' principle related to the law of flotation? Now, I want us to understand something. When we were defining Archimedes' principle, we said that that object that is immersed in a fluid will always experience an upthrust that is equal to the weight of the fluid that is displaced. In this particular context, it means that you cannot know the upthrust unless you calculate the weight of the fluid that is displaced. But in the law of flotation, as long as you know the weight of the object that floats on that particular fluid, then definitely you should be able to know the weight of the fluid that is displaced, because the weight of the fluid that is displaced is equal to the weight of the object. This same weight is equal to the upthrust. In a nutshell, the law of flotation is just a special form of Archimedes' principle, only that these only apply for a floating object. Any other object, then we will not be talking about the law of flotation. Let us use this diagram to answer the question that follows. Now, from the diagram, we have a cube of side 1 meter. Now, this cube floats on the surface of two liquids, one being water and the second one being ethanol. Now, on water, the depth that is underwater is 0.4 meter, while for ethanol it is 0.3. Now we've been given the density of water as 1,000 and that of ethanol as 800, and we've been given the gravity as 10. Now we want to see, we've now been asked the density of that particular cube. This will be a long question, but I want us to take it step by step so that we understand how we can tackle such kind of a question. Now, since we've been informed that that particular cube floats on the surface of those liquid, here we are going to adopt the law of flotation that says that upthrust is equal to the weight of that object, the weight of the cube. I want us to remember where we started. We said that upthrust is equal to the weight of the fluid displaced. And now, the first assignment here will be to calculate the weight of the fluid that is displaced. But here, we have two liquids that we are talking about, one being water and the second one being ethanol. Now, the first thing will be to calculate the individual weight of the fluid that is displaced, so that from there we'll now go ahead to link it up to the weight of the cube. Now, if we begin with water, we've been told that only 0.4 meter of the cube was underwater. So we will get the volume of that, which is 1 multiplied by 1 multiplied by 0.4, giving us 0.4 cubic meter. And now we go ahead now to calculate the mass by multiplying a volume to density. The density of water is 1,000. So if we multiply 0.4 to 1,000, we'll get 400 kilogram. And now we take the 400 kilogram and we go ahead to find the weight. And now to get the weight, you have to multiply the mass to gravity, and the gravity we've been given as a 10. So if you multiply 400 to 10, we are going to get 4,000 Newton as the weight of water that is displaced. Now, we are going to use the same procedure to calculate the weight of ethanol that was displaced. We've been told that only 0.3 meter height of that particular cube was under ethanol. So if you get the volume of that, we are going to multiply 1 by 0.3. That will give us 0.3 cubic meter. Now we go ahead to multiply that to the density of ethanol, which is 800, to give us 240 kilogram as the mass. Now we take that mass, we multiply by the gravity, which is 10, to give us 2,400 Newton as the weight of the ethanol that was displaced. The next thing will be to bring together the total weight of the liquid that was displaced. Now we are going to add the weight of water displaced to the weight of ethanol displaced. So if we add 4,000 Newton to 2,400 Newton, we get to 6,400 Newton. Now 6,400 Newton becomes now the total weight of the fluid that was displaced. Now, how do we use this value 6,400 Newton? Remember, according to the law of flotation, we were told that the weight of the fluid that is displaced is equal to the weight of that object. It therefore means that 6,400 also qualifies to be the weight of that particular cube. Now that we have the weight of the cube, we can divide this by the gravity, which is 10, to get to the mass of this particular cube. So if we divide 6,400 to 10, we get 640 kilogram as the mass of the cube. Well, since we've been given the dimension of the cube, we can go ahead to get the volume of that particular cube by multiplying 1 to 1 to 1, so that we get the cube as 1 cubic meter. Now, we already have the mass as 640 kilogram and the volume as 1 cubic meter. Now, to get the density, we have to divide the mass by the volume, so that if we divide 640 kilogram to 1 cubic meter, we will have the density of the cube as a 640 kilogram per cubic meter. And now this one becomes our final answer.